Hey folks! After watching the last video, you now know the basics of universal gravitation. However, you have not yet had a chance to watch a problem solved out. So that's what this video is going to cover. To make our lives easier, I've written here the equation for universal gravitation and the value of our gravitational constant g, which is, as always, 6.67 times 10 to the negative 11th. Without further ado, let's go ahead and get into the problem. And as I'm going through the problem, I'm going to go ahead and highlight my givens, each in a different color. Let's get started. One grim fairy tale tells the story of a bird, a mouse, and a sausage. It is a very weird fairy tale. If the bird has a mass of 5 kilograms and is 20 meters away from the sausage, which has a mass of 2 kilograms, what is the force of gravity between them? So, we're going to go ahead and start, as we always do, by listing out our givens. And I'm going to start with my green given, which is 5 kilograms. And that 5 kilograms is the mass of the bird, which, as you can see, is the larger of our two masses, and so is going to be my capital M. To go with that, I have the mass of the sausage, it's lowercase m, which is 2 kilograms. And the two are 20 meters apart from one another, and that is going to be my radius between them. They are both small enough that I'm going to assume that their centers of mass are pretty much as far away from each other as they are, or at least close enough to a point where it is not important, not relevant information to try to calculate their centers of mass, because that is beyond the level of this course. Anyhow, let's go ahead and go forward and figure out our unknown. Now, our unknown in this situation is the force of gravity between them. Them, of course, being the bird and the sausage. So our unknown is the force of gravity between the bird and the sausage. And the equation we're going to use to figure out that force is our gravitational force equation. So our equation is F sub g, the force of gravity, is equal to the gravitational constant g, capital G, times capital M and lowercase m, our two masses, divided by the radius between them squared, so the distance between them squared. Let's go ahead and substitute in numbers. Substitution, our substitution step. We have F sub g is equal to 6.67 times 10 to the negative 11th, which is our value for capital G, the mass of the bird, which is 5 kilograms, the mass of the sausage, which is 2 kilograms, and finally the distance between them squared, or 20 meters squared. And what we are going to get when we multiply that out is our solution. Go ahead and just write that out. We get, and you will find this if you stick this in your calculator, that the force between them is 1.7 times 10 to the negative 12th newtons. And that newtons, of course, is always going to be our unit for a force. Now, let's get a sense of how big that actually is. So, in non-scientific notation, let's go ahead and write out what our number would be. And remember, when we're going from scientific notation to regular notation to decimal notation with a negative number, we are going to move our decimal point 12 places to the left and fill all those extra spaces with 0. So you guys can go ahead and try this on your own, but I'm going to go ahead and write out what that will look like. So we've got 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros, 1, 7. Newtons. And that is going to be the force of attraction in non-scientific notation between the sausage and the bird, which of course is why it is important to know how to do scientific notation, because nobody wants to write this many zeros. So this is how your answers should actually look. Use scientific notation. Now, guys, what I want you to try and do is figure out what would happen if we doubled the distance between the bird and the sausage. I'm going to go ahead and write that up here for you. What happens to FG if the distance increases to 20 meters? I want you to go ahead and solve that out. And what you should find is FG is 4 times smaller. So our new FG is equal to our old FG divided by 4. If you look at the equation, you should be able to figure out why that is, but I want you to go ahead and solve out this problem and just prove it for yourself. Once you have done that, you can go ahead and start the universal gravitation problems that are posted on Google Classroom.